Motional EMF from Lorentz force. So to find out the motional EMF from Lorentz force, we have to consider a straight conducting rod. Here this is a straight conducting rod with length L, and it is placed in a uniform magnetic field. The rod is kept perpendicular to that of the magnetic field, and the magnetic field is perpendicular to that of the paper. Okay. So the length of the rod is L. So it is kept perpendicular to that of the magnetic field. Okay. Now the rod is moving with a velocity v towards the right side. So it is moving with velocity v towards the right side. Now when the rod is moving, the free electrons present in the rod will also move with the same velocity. There are many electrons present in the rod. These electrons will also move with the same velocity. So the Lorentz force act on the free electrons will in the direction from B to A. So there is a Lorentz force because the rod is kept in the magnetic field. As the electrons move in the magnetic field, it will experience in a magnetic force. Okay. So that force is nothing but the Lorentz force. Now the Lorentz force is given by the relation F B vector is equal to minus E into V cross B. E is the charge, V is the velocity, and V is the magnetic field. This is the magnetic force. Okay. Now, the action of the, because of the action of the Lorentz force, the free electrons will accumulate at the end A. Okay, all the free electrons will accumulate at the end A. It will move from B and let at A. Okay. Now, because of this accumulation of free electrons produces a potential difference across the rod is establishing an electric field. There develops a potential difference across the rod because of the electrons. Okay. And it will produce a magnetic electric field around from B to A. Okay. Now, because the electrons are moving from the positive to the negative. So always the electric lines of force will be moving from what, positive to negative. So there will be an electric field is produced. The electric field is due to the Coulomb force. Okay. So the Coulomb force is given by F E vector is equal to minus E E vector. F E vector is equal to minus E E vector. So we have learned the Lorentz force as well as the Coulomb's force. So when the charge is moving in the magnetic field, it produces a Lorentz force. When the charge moves inside the rod, it produces a electric field. Okay. Now, the magnitude of the electric field is, it keeps on increasing as long as the accumulation of the electrons at the end A continues. Okay. So the magnitude of the magnetic field, electric field is keep on increasing as long as the electrons are moving from B to A. So the accumulation in A is keep on increasing. Okay. So this also increases the electric field until a equilibrium is reached. Okay. So as the electrons are moving from this B end to A end, there will be an accumulation of electric charges in the end A. Okay. That will increases the electric field until it is increasing the electric field. Okay. It is coming to an equilibrium. Now at equilibrium, the magnetic Lorentz force and the Coulomb force, they will balance each other. So the magnitude of the magnetic Lorentz force FB is equal to magnitude of electric field. Okay. Now we can equate both. So we can write minus E V cross B is equal to minus E into E. So we are taking the modulus in order to eliminate the minus sign. So this can be written as V cross B can be written as, what is we can write, minus EVB sine theta. Minus EVB sine theta is equal to EE. Okay, minus and minus will go away. my E and E will get cancelled. V cross B is VB sine theta. Here theta is 90 degree. That is the direction between the velocity and magnetic field is perpendicular. So it is 90 degrees. So it is equal to E. Okay. So we can write V is equal to EB since sine 90 is equal to what? 1. Okay. Now the potential between the two ends of the rods. There exists a potential between the two ends of the rods, that is electric field into length. Potential is equal to electric field into length. I'm going to substitute for electric field as VB. Okay. So when I substitute for electric field as VB, V is equal to VBL. Okay, the potential difference is equal to V velocity into magnetic field into length. Okay. Now here, this is nothing but the Lorentz force. So the Lorentz force on the free electrons is responsible for maintaining the potential in the rod, and therefore it induces an EMF. So this potential is giving the EMF. So the EMF can be written as BLV. The EMF can be written as what? BLV. Now this EMF produced due to the movement of the rod, because it is having the velocity V. So since the rod is moving, only the EMF is produced. That is called as the motional EMF. That is called as what? Motional EMF. If the ends A and B are connected to an external resistance, so across the conductor we are connecting an external resistance, then current will flows in it. So I is equal to E by R. That is epsilon by R, EMF by resistance according to Ohm's law. What is the EMF? EMF is equal to BLB. BLB by R. BLB by what? R. Okay. So the current in the circuit is what? BLB by R. Now what is the direction of the current? The direction of the current is according to what? Which rule? Right hand thumb rule. Okay. So we have found out the expression for the motional EMF. From that we have found out the expression for current.